Hi students, here is your science reading today for energy. We're going to start out with page 122 where you see actually the pendulum on the bottom. That's where we're going to start. And we're going to look at the top, these top three paragraphs where it says kinetic and potential energy. The first thing that you need to do is you need to box and shade kinetic and potential energy because that is our topic. Okay, so do that now, and then you're going to number the paragraphs. Number 1 by kinetic, number 2 by falling object, and number 3 by pendulum. Okay, do that now. All right, students, we are actually not going to read the first paragraph. It is about some examples, and it's not necessary for our reading today. So we're going to go down to paragraph 2, and we're going to start with a falling object. Okay, so I am reading out loud. You are reading with me as I track the words with my arrow. So you are reading in your head. Be ready to answer some questions when we pause the video. Here we go. Falling object. A transformation or change between potential and kinetic energy occurs in the ball in figure 1. Look at the ball here, where there you see a hand. Someone was holding the ball and then they let it go and it fell. As the height of the ball decreases or goes down, it loses potential energy. At the same time, its kinetic energy increases because its speed increases. Okay, its potential energy is transformed into kinetic energy. So let's take a look again. At the top, the person holding the ball, it is not moving and it has a lot of height. Then, when the ball is dropped, it gets less potential energy because its height is going down, and it gets more kinetic energy because it moves faster and faster and faster. Okay? A pendulum. A pendulum, like the one in figure 2 below, swings back and forth. At the highest point in its swing, the pendulum has no movement. Okay? So when it gets to the top, it stops for a split second. You almost can't even see it, but it does stop. So up here it has height and no movement for a brief second. As it swings downward, it speeds up. The pendulum is at its greatest speed at the bottom of the swing. As the pendulum swings to the other side, its height increases and its speed decreases. At the top of the swing, it comes to a stop again. Okay, students, let's take a look here. This figure 1, it says the falling ball. Let's look at that first. The ball was photographed at equal time intervals as it fell. So right here, a picture was taken here, a picture was taken here, a picture here, and a picture here. Okay, so 1, 2, 3, 4 pictures to show you that it's falling. Okay, how can you tell that the ball's kinetic energy or movement is increasing? How could you tell that the ball is getting faster? So look at the ball from this picture to this picture. What do you notice? From this picture to this picture, what do you notice? From this picture to this picture, what do you notice? From this picture to this picture, what do you notice? So talk about the spaces between each picture. How do you know that the ball is getting faster? Answer the question right here. All right, students. Next, let's take a look at the pendulum that we talked about in paragraph 3. A continuous transformation between potential and kinetic energy occurs in the pendulum. Okay? So we need to label what energy is at in A, where the ball is at the top and it stops for a brief second. At B, where the ball is at the very bottom and has no height, but it's still moving. And then C, when the ball is at the top again and stops for a brief second. Which one of these are kinetic and which one of these are potential? Okay, pause the video and label them now. All right, students, next, we are going to talk about the law of conservation of energy. So you need to box and shade this title and put a paragraph number 1 next to once. Do that now. All right. Again, I am going to read and you are going to read along in your head. Once you set a pendulum in motion, does it swing forever? No, it does not. Then what happens to its energy? Is the energy destroyed? Well, again, the answer is no. Because the law of conservation means save, of energy states that when one form of energy is transformed to another, no energy is lost in the process. So if we go from kinetic to potential, it should be the same energy, the same amount. And then if we go back from potential to kinetic, it's the same amount of energy. According to the law of conservation of energy, energy cannot be created or destroyed. The total amount of energy is the same before and after any transformation. If you add up all the new forms of energy after a transformation, all of the original energy will be accounted for, it will be there. So what happens to the energy of the pendulum once it stops moving? Okay, so that is something to think about. Let's take a look at our roller coaster. It says, how is energy conserved in transformation, or how is energy saved? Transformations between potential and kinetic energy occur during a roller coaster ride. Use what you've learned about energy to answer questions 1 through 3. Okay, so let's take a look. Here it says, the roller coaster starts from rest at the top of the first hill. So if you've ever ridden a roller coaster, maybe you're aware that once you get to the top of the hill, the roller coaster kind of pauses for a moment. Okay? So shade in the bars to show approximately how much potential and kinetic energy the coaster has at each point. So when the roller coaster is at the top of the hill, how much potential are you going to shade? Are you going to give the roller coaster all potential energy and color in the whole bar? Or does it only have half potential energy? Or does it have no potential energy? At the top of the hill, how much kinetic energy does it have? Does it have all kinetic energy? Half? None? You're going to shade how much each has. Okay? Then, when the roller coaster is in the middle of the hill, how much potential energy is there? How much kinetic energy is there? And then when the roller coaster is at the bottom, how much potential, how much kinetic? Okay? All right, students, you're going to pause the video and you are going to fill in your shaded boxes now. All right, students, if you have any questions about this or the questions on your Ed puzzle, please check in with your teacher. Thanks.